All right, before we get started in the first section here, we have a quote. Grit and perseverance are better predictors of academic success and achievement than talent or IQ. And I think that's especially appropriate for math because a lot of people think if they're not good at math, then they can't really do well in math. And this quote is, I think, very true, that more of your math success will be based on your grit and perseverance than anything. So, section 1.1 here, classifying a real number. This is from the OpenStax textbook, OP textbook, college algebra, section 1.1. Natural numbers are numbers starting with 1, and they're just the counting numbers all the way to infinity. Go kind of quick here. This is pretty basic review. So whole numbers just include 0. All the numbers, counting numbers all the way to infinity. Integers include all the negative numbers. So, and also all the positive counting numbers as well. And rational numbers. They're ones that can be written as a fraction. So they don't always look like a fraction, but they can be written as a fraction, as an equivalent fraction. So if they're decimal numbers, they're going to be either repeating or terminating. So let's try some examples here. Try it number 1. 11 can be written as 11 over 1, so it's rational. 3 is 3 over 1, so it is rational. 4 is negative 4 is negative 4 over 1, so it is rational. Let's try some others here. 68 over 17 is equal to 4, which can be written as a terminating decimal 4.0, so it's rational. 8 over 13. If you put it into your calculator, let's try one example. You can use a calculator or mathway.com, and eight over 13 is equal to this 0.615384 with a bar over it. .615.834 with a bar over it just means all these numbers keep repeating. And then negative 17 over 20 is equal to negative 0.85. So it's a terminating decimal. So what are irrational numbers? Ir just kind of means not, so it cannot be written as a fraction. And some classic examples are like the number pi, square root of 2. So let's look at a few to try to determine if they're rational or irrational. So try it number 3 here, 7 over 77. My notes here. Putting this into, you can put this in a calculator and you get equal to 0.09 repeating. So just 0.090909 on and on forever. And since it's repeating, it's rational. And square root of 81 is 9. Which can be written as a fraction, so, and also a terminating decimal. So it's rational. And this one kind of looks like a repeating pattern, but it's not, because you have 270, then you need 270, and then you need 270 again, but you have an extra 0 here, so it is not repeating. So it is irrational. 91 over 13 equals 7.0, a terminating decimal. And so it is rational. Square root of 39 is 6.24499. 799 and ... It continues on, no repeating pattern, so it is irrational. All right, so let's take a look at real numbers here. So classify each number as positive or negative, and rational or irrational, and to the left or to the right of 0 on the number line. So square root of 73, a lot of calculator work here, 8.544000374 ... It's no repeating pattern, so it's irrational. It's positive, and so it's to the right of 0. Number line is a pretty basic concept, but still good to review a little bit. Make sure you understand fully kind of what it looks like and how it's used. So here we have a repeating pattern, 411. So it's rational. And it's a negative number. Negative sign out front of it, and it's to the left of 0. 47 over 19. Forgot to put this one on my notes, so let's go ahead and work it out. And by work it out, I just mean plug it in. So we get 2.4736 8421. And it didn't have a bar over it, and it has ... So it is not repeating, it's irrational. It's not terminating either. It's negative. No, it's not negative. It is. Let me double check that. My notes had something different. 47 divided by 19. All right. 473684221. It's interesting. Is this a rational number? Duh. It's a fraction, so it has to be a rational number. All right, let's look back at this. Since it's fractional, it has to be rational. But this is a good example because you can see when you do it in mathway.com by the decimal, if you were to see this decimal here, it wouldn't be clear that it's repeating or terminating because it's ... So, but it's rational because it's a fraction. We didn't have to do the dividing because it's already a fraction. We can already tell it's rational. And it's to the right of 0. All right, negative square root of 5 divided by 2 equals... This is a fraction. I guess I didn't define it completely clearly. It's a fraction, but it's not. Has a square root in it, so it's not. To be a rational number, it has to be a fraction where the numerator and denominator are whole numbers, or integers. So this is, if square root of 5 is an integer, then it is going to be rational. But if you put this in your calculator, you get negative 1.11803398. No repeating pattern, so it's irrational. And it's negative. And therefore it's to the left of 0. And, anytime you see a negative sign, it's going to be to the left of 0, but you may get confused and thinking square root of 5. I have no idea where that is on a number line, but it's important to know that no matter what square root it is, I might confuse it a little bit, but if it's negative, has a negative sign, it's going to be to the left of 0. And then 6.210735, it's terminating. It doesn't have a ... so it's rational. It's positive, and it's to the right of 0. All right, show with a diagram how most of the numbers discussed are subsets of other types of numbers. So you can do this different ways, but the smallest group of numbers of all of these is n. So we'll make that a small circle. Let's make it a little bigger so we can fit n inside of it. And then the next smallest, a little bit bigger because it includes 0, are the whole numbers. And then bigger than that are the integers. They include all the negative numbers. And bigger than that are the rational numbers. And then everything else outside of all these circles are the irrational numbers. All right, try it number 5. Classify each number as natural, whole number, integer, rational, or irrational. So negative 35 over 7 equals negative 5. So which numbers is this a description of? Is it natural? No, because it's negative. It's not whole because it's negative. It's an integer. And it's a rational number because it can be written as negative 5 over 1 is a fraction. So 0. So this one also is a whole number, and it's an integer, and it's a rational number. 0 over 1, you could write it. So it is rational. Square root of 169 is 13. So this includes all the ones we discussed. It fits the description of all of them, except irrational. Square root of 24 is 4.8989. 0.7948. And this is irrational. Its number goes on and on. It's not exactly repeating 8989798. And then the last one here is repeating. 763 repeats, so it's a rational number. And it's not natural or whole because it's a decimal number. So let's look at the next section here. Performing calculations using the order of operations. What does exponential notation, A with a N a little bit above it, what does it mean? It means it's kind of a short way to write A times A times A, and just keep multiplying A as many times as this number up here is. So sometimes they write it like this, like the first A and then A as many times as N. And sometimes described as N factors because they're all being multiplied together. Those are factors. N factors of A. Probably important to do a quick example. So 2, it would be described as like 2 to the third power. And that would be equal to, you multiply 2, factor it out as many times as this number up here. So you'd multiply by itself 3 times. So 2 times 2 times 2 equals 8. So 2 to the third power. Let's get into describing what these are called. A is called the base. And N is called the exponent or power. And another definition here. What is a mathematical expression? And maybe not an essential definition to know, but it's just a combination of numbers and operations. It's kind of a definition setting us up for what is an algebraic expression. And by operations, we just mean like plus, minus, multiply, divide. So we evaluate or solve mathematical expressions in an orderly fashion by using what's called and that orderly kind of gives it away, and you get a chance you already know this, but it's called the order of operations. And this is critical to math, algebra, knowing how to do it, solve your problem in the right order. So the acronym used to help remember what order is called PEMDAS. And you can write it PEMDAS, PEMDA. Actually, I'm going to write the M and the D on the same line, and I'll describe why in just a moment. So the P stands for parentheses, and the E for exponents. The M and the D are multiplication and division. And A and S are addition and subtraction. Those you would do last in a mathematical expression or a problem. Addition, subtraction last. So parentheses includes all grouping symbols. So it would be, of course, parentheses, but also other grouping symbols like brackets and braces and a division symbol, like if you had 2 plus 3 over 4 minus 2, you would do what's above the division symbol before you do what's below. You do those separate. You wouldn't go like 2 over 4 and then 3 over -2. And then another one is square root. You would do what's under the square root sign before you do something else. And the reason why I put multiplication and division, so exponents, yeah, that would go next. And then multiplication and division I have on kind of the same line here because you go in an order from left to right. So if you have 6 divided by 2, divided by 2 times 3, you do the division first. But if you have 6 times 3 divided by 2, you do the multiplication first because you go in order. Whichever one comes first of multiplication and division, you do that one first. And similar with addition and subtraction, go in order from left to right. So let's look at a few problems here from the try it number 6. So this square root is a grouping symbol. We'd want to do what's under here first. And so 5 squared you'd want to do before subtraction. So you want to do 5 squared minus 4 squared. So that would be, you want to do everything under here first. So 5 squared would be 25 minus 4 squared would be 16. And then we want to focus on what's inside the parentheses next. 5 minus 4 is 1. And then just kind of leave everything else how it is and go to the next step. So we want to finish doing what's under the square root. Here, 25 minus 16 is 9. Still have the square root sign. Plus 1 squared is 1. So 7 times 1 squared is just 7. And then the last step is to take, well, I guess maybe we have technically 2 steps, but square root of 9 is 3. And then 3 plus 7, because you always do addition, subtraction last. 3 plus 7 is 10. Next one here, once again, you have a grouping symbol, the division symbol. So you would do what's above it and what's below it separately. You do addition last, so just leave addition alone for now. So 7 times 5 is 35. 8 times 4 is 32. Over 9 minus 6 is 3. And you might ask, why aren't you dividing? This is division sign. Why don't you do that before you're doing your subtraction here? Well, once again, it's a grouping symbol. So you've got to do everything above everything and everything below separate before you do your division. So this is equal to 1 plus, we can't add yet because we have to finish this part. 35 minus 32 is 3 over 3. And that's equal to 1 plus 3. Now we can do 3 divided by 3 is 1. 1 plus 1 equals 2. All right, let's look at least one more here. So, didn't say it earlier, but these bars here are absolute value, so they are a grouping symbol as well. So you do everything in here separate before you add. So 1.8 minus 4.3 is negative 2.5. Leave it inside our bars here, plus 0.4, and 15 plus 10 is 25. So this all equals square root of negative 2.5. When you take the absolute, or I said square root, the absolute value. When you take absolute value of something, it becomes positive. So this is just 2.5 plus, and here you do the square root first before you multiply times 0.4. So square root of 25 is 5. And now you have 2.5 plus 0.4 times 5 is 2. And then now you can add those together and get 4.5. A lot of this just takes practice. It can be a little confusing. The order of operations seems very straightforward, but it can be just a little bit confusing. All right, let's quickly go through another one here. So here you have, got to do what's inside the brackets here first. So you have 1/2 times 5, and you want to do exponents before you do the multiplication. So 3 squared is 9, 7 squared is 49, plus 1/3 times, do the exponents first, 1/3 times 81. And you've got to finish what's inside the brackets here first. So you get 1/2 times 5 times 9 is 45. Plus, now you can do 1/3 times 81, which is just 27. 81 over 3 is 27. Now you can finish what's inside the braces here, or the brackets. Get 1/2. 45 minus 49 is negative 4. Plus 27. 1/2 times negative 4 is negative 2. Plus 27 equals 25. Negative 2 plus 27 equals 25.